Hi, this is Cade Havel. I am making my 80% video for volumes of the solids with known cross-section project. And first off, to find my functions, I used GeoGebra. And my functions were f of x equals sine times the quantity x minus 1.75 plus 3, and g of x equals cosine times the quantity x minus 1/4 plus 1.1. When you graph those two functions, you get something like this. Also using GeoGebra, I found the intersection points, which I will share with you later on. Well, how about right now, actually? So to do my actual cross-section volumes, I used 0.6, which is slightly greater than 0.53, to 6 on the integral, which is slightly less than 6.18. And when I flipped my coin, I got right isosceles triangles as the base, with the hypotenuse as a base, excuse me. And I thought, oh, what shape could I make with that? I noticed the graph looked kind of like lips. So, therefore, I did the picture and came up with this. You may recognize this man, very popular in the calculus community. And there's a picture of the triangles. I cut it close with the laminations, used 41, and the requirement was 40. As you can see, all of them are in there. And some troubles making the laminations. Here's a razor blade. Cut this finger. Also slice this one a little bit. But other than that, neatness was pretty tough, but other than that, went pretty smoothly. Okay. So the integral for right isosceles triangles is the integral f of x minus g of x squared times 1/4. And using my functions, I got 8.807119. And when I did my Excel sheets with these laminations, I got 8.806692. As you can see, there's a little bit difference there, but that's pretty much what you're supposed to get. For equilateral triangles, I got the integral from 0.6 to 6, f of x minus g of x squared, with respect to x, times this root 3 over 4, equals 15.254377. When I did my Excel sheets, using 41 laminations, I got 15.253639. For pentagons, this one was a little confusing. I had to Google this up for the formula, and what I got, the integral 0.6 to 6 of f of x minus g of x squared times that thing, the glomp, with respect to x, equals 60.609795. And when I got my Excel sheets, I got 60.606863. Semicircles. Volume was from 0.6 to 6, f of x minus g of x squared, with respect to x, times pi over 8, equals 13.834189. And when I did my Excel sheets, 13.833521. Right isosceles triangles leg as a base. Volume equals 0.6 to 6, integral from 0.6 to 6, f of x minus g of x squared dx with respect to x, times 1/2, 17.614237. And with my 41 laminations using Excel, 17.613385. When I use Excel, all of the volumes are slightly lesser of a volume than when I did the exact integral, but that makes plenty sense because Gives you a little room for error using these bad boys. And I think that's pretty much it. I'll leave you with this gorgeous view of Mr. Williams.